The James Webb Space Telescope is about to begin investigating astounding light shows happening on one of the giants of the solar system, Uranus. These mysterious lights have been puzzling scientists for a long time, and for a good reason. The main goal of the $10 billion space telescope will be to explore in greater detail the processes creating polar light shows over different planets. Auroras are familiar to people on Earth. We have stunning northern and southern lights, which can be observed along the poles of our planet. They're generated when charged particles streaming from the sun's solar wind hit our planet's protective magnetic field called the magnetosphere. These particles then travel down magnetic field lines and interact with particles in the atmosphere of our planet, creating glowing lights. Auroras have been spotted over other planets in the solar system before. Theoretically, they should be able to occur around any planet with an atmosphere and magnetic field. However, not much is known about extraterrestrial light shows. Currently, we know very little about auroras on Uranus. This is an ice giant with an atmosphere that consists of water, ammonia, and methane. It was just last year, after 3 decades of investigation, that a research team confirmed an infrared aurora around Uranus. Due to a collision with a roughly Earth-sized space body that occurred in the past, Uranus is tilted at a 97.77-degree angle. In other words, its poles are oriented almost directly toward and away from the Sun, and its auroras are positioned around the area that would normally be the equator for any other planet in the solar system. Along with observing auroras on Uranus, researchers will also try to find the answer to an intriguing question. Are auroras responsible for keeping this icy planet warmer than expected? The temperatures of all the gas giant planets in the solar system, including Uranus, are hundreds of degrees above what they should be if these planets were only warmed by the sun. The big question is, what makes these worlds so much hotter than expected? One theory suggests that auroras could be the reason. They could generate heat and push it down toward the magnetic equator. James Webb is supposed to start its study of Uranus early in 2025. The telescope is going to capture images of the ice giant over a single planet's day. It lasts around 17 Earth hours. Hopefully, it will allow the research team to map auroras across a whole rotation of the magnetic field of the planet. Scientists also want to find out whether Uranian auroral emissions are produced when the magnetic field of the planet interacts with the solar wind, as it happens on Earth. Another theory states that charged particles might be coming from sources within the planet, similar to how Jupiter produces its auroras. On the largest planet in the solar system, charged particles trapped in the magnetic field around the planet spiral inward toward the north and south magnetic poles, producing auroras. Another aurora researching project involves gas giant Saturn. Astronomers are going to observe this planet's northern auroral region for an entire Saturnian day, which lasts 10.6 Earth hours. This will allow the team to monitor how the temperature in that region changes as Saturn rotates. By examining Saturn's atmospheric auroral energies for the first time, experts hope to find out more about the sources of charged particles driving the planet's auroras. Some of Saturn's auroras might be caused by swirling winds within the planet's atmosphere. This previously unknown mechanism of triggering atmospheric light shows hasn't been seen on any other planet before. Saturn is actually one of the windiest planets in the solar system, with wind speeds reaching almost 1,120 miles per hour near the equator. These powerful winds seem to be responsible for the planet's variable rotation rate, which makes it difficult for astronomers to figure out how long the day lasts on the ringed planet.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. it has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's Infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night. And suddenly, there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon. But then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, the flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has 2 cameras controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon, being in the shape of a horn, begin to split in 2 from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the moon. We can blame this on meteorites that fall on the surface. Because the moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the moon. NASA confirmed this fact after studies with the Sophia telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the Moon. These places have never seen light, and the water there might be encased in ice. But Sophia found water on the sunlit surface of the Moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the Moon. But an even more unusual phenomenon is happening there right now. The Moon is actually rusting, just like a piece of old metal. For rust to appear, we need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the Moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the Moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the Moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the Moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the Moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the Moon, there's a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the Moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armored tanks or 3 large passenger planes. Strange, but true. Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal. If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, For example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. They can also be produced industrially. The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus? Totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw. But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas. So now, does it mean there's life on Venus? Well, not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet. Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine. Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again. If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars. If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more. And then, things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the Sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither. It would take between 1,000 and 81,000 years for a spacecraft to reach Alpha Centauri if we used conventional propulsion. Plus, astronauts would have to deal with the countless risks of the mostly unexplored interstellar medium. But there might be a way out of this seemingly hopeless situation. Gram-scale spacecraft that rely on lasers when it comes to traveling through space. One of such concepts is called the Swarming Proxima Centauri, and it has recently been chosen for the NASA Innovative Advanced Concepts program. You see, traveling through interstellar space is a question of speed, energy, and distance. Proxima Centauri sits 4.25 light-years away from the solar system. That's 25 trillion miles, which is incredibly far away. For comparison, the farthest distance ever traveled by a spacecraft is 15 billion miles from Earth. Voyager 1 has been moving in outer space for more than 46 years, reaching a maximum speed of over 38 miles per hour. Traveling at the speeds that we can allow at the moment will make interstellar transit exceptionally long and totally impractical. And don't forget about the energy requirements such a journey would demand. Anything other than a tiny spacecraft weighing a few grams doesn't look feasible. But the solution might have been found. Bouncing photons off of a laser sail could solve the speed problem. But since a single photon doesn't have much momentum, a lot of them are needed. And since even in a couple of decades we probably won't have a lot of power available, the thrust will be weak. That's why the mass of the probes has to be minuscule. Not tons, but grams. The proposal suggests using a 100 gigawatt laser beamer, boosting thousands of tiny space probes with laser sails to a speed of 10 to 20% of the speed of light. This mission concept might be ready for development around mid-century. Then, the probes could reach Proxima Centauri as early as 2075. The researchers involved in the project have already demonstrated how a fleet of 1,000 spacecraft could deal with the difficulties of interstellar travel while maintaining communications with Earth. At the same time, the 8-year round-trip time lag caused by interstellar distances and general relativity makes it impossible to control the swarm of the probes from our planet. That's why the fleet must possess a great degree of autonomy when it comes to navigation and deciding what data should be delivered to Earth. One more issue is the cost of such a mission. The greatest expense will be the laser array, while the tiny probes might be reasonably cheap to produce. The scientists believe that their project can be developed with a budget of $100 billion. It's not so much compared to the usefulness of such a mission, which is likely to be astronomical. How come? Red dwarf Proxima Centauri, which is a member of the Alpha Centauri star system, has an Earth-like planet orbiting it, Proxima Centauri b. It's the closest exoplanet to Earth. Its mass is similar to that of our planet, and it travels in the habitable zone of its parent star, which means there might be water in this world as well as an atmosphere rich with oxygen. This planet might harbor life, or it could be a dry rock. In any case, it's a promising target in the search for alien life. Unfortunately, we can't detect the planet's biosignatures because our usual methods for detecting them don't work with Proxima Centauri b. Most exoplanets are discovered and explored through the transit method, where a planet regularly passes in front of its parent star, and we see a recurring dip in the star's brightness. That's how we know that the planet is there. But Proxima Centauri b isn't a transiting planet. It was discovered by a different method. When we look at the light coming from Proxima Centauri, we can notice that the gravitational pull of Proxima Centauri b makes the star wobble a bit. That's how astronomers found out that the planet was there. They also managed to estimate its size and mass. But no one can figure out much more than that. Hopefully, a swarm of tiny space probes will help us solve this mystery.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the Kraken or Leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes. 2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable? For us. Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect. But when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets, and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency! Toys R Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys R Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of two exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these two Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these two new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with two instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun." Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys R Us, Wolfie and her mama will all be out there waiting for us. Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere, there are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow has survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for 1 billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of 2 galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Space. Dark, lifeless, and quiet, right? Well, apparently it's not always true. Recently, scientists have detected an eerie echo coming from the main black hole in our galaxy. It has high and low notes and sounds pretty otherworldly. What does it mean? Should we sound the alarm bell, siren, whatever? Sagittarius A star is our own supermassive black hole, sitting right in the center of the Milky Way galaxy where we live. You might know that black holes are the true monsters of our universe, gobbling up everything that is careless enough to come too close. If a massive black star runs out of its star fuel, It sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing becomes so strong that nothing can escape it, not even light. And so goes a black hole. We really can't see black holes since they devour everything, even light. But we can still figure out where they're located, all thanks to the existence of accretion disks. Want an explanation? Well, picture a black hole. The starving thing consumes all the matter that strays too close, squeezing it into a superheated disk of glowing gas. The black hole also bends light around it, which creates a circular shadow. That's what I mean. We can't see a black hole itself, but we can see the accretion disk surrounding it. It happens like this. First, the material gets caught in the black hole's orbit and squeezed into a razor-thin spinning band. Friction, heat, electric, and magnetic forces energize this disk, which makes the material glow intensely. The most massive black holes have such bright bands that they can outshine millions of galaxies. Inside this disk of glowing material, particles rub against one another. It slows them down and sends them straight toward the black hole's event horizon. If this friction didn't exist, the material would be orbiting the black hole for billions of years, like planets circling around their stars. Now, let's get back to Sagittarius A star. It's far less luminous than other black holes at the center of galaxies astronomers have observed. It means that, at the moment, our central black hole isn't actively munching on the matter surrounding it. What, is it catching some Z's? The answer is unclear. There's new evidence received by NASA's Webb Telescope. It suggests that the seemingly sleeping giant woke up pretty recently, about 200 years ago. Ooh, that is recent. It snacked on gas and all kinds of cosmic debris within its reach. Why did it happen? And what did the black hole do after that? Sagittarius A star is the nearest to us supermassive black hole, just 25,000 light-years away from Earth. Its estimated mass is millions of times greater than that of our Sun. It sounds impressive, doesn't it? So, when scientists spotted relatively recent X-ray emissions of ginormous clouds of gas in the vicinity of the black hole, they immediately called on the Webb Telescope to figure out what it may mean. What intrigued them most was how bright these clouds were. You see, most cosmic clouds, called molecular clouds, are dark and cold, with their X-ray signatures very faint. But that wasn't the case with this finding. Of course, there are a few theories concerning this phenomenon. One of the main explanations for why these giant molecular clouds are shining so bright is that they just echo a long-gone flash of X-ray light. It could mean that our supermassive black hole might not have been that dormant some centuries ago. After additional research, astronomers figured out that the X-rays coming from the giant molecular clouds were actually reflected light. And this light must have come from a short-lived and extremely intense flare that was produced either very near or right at Sagittarius A star. And the most likely cause of it is the black hole suddenly consuming a huge chunk of the material surrounding it. It happened around the start of the 19th century. It was most likely a sight to behold. Whirlpools of particles were drawn toward the black hole's event horizon, also known as the point of no return. The black hole started to ingest all this material, which resulted in brilliant bursts of X-ray light and echoes that we managed to translate into sound waves here on Earth. This discovery is crucial for understanding the processes happening to and around our supermassive black hole. We might also figure out what physical processes can potentially awake Sagittarius A star again, even if this period of activity is just temporary. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times the mass of our Sun. And two such giants have been recently spotted with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, mercifully also known as ALMA. Two gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars tucked close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Interestingly, such immense merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe these bright and compact regions where matter swirls around black holes. Imagine how surprised they were when, instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. And if before, experts thought that such galaxy mergers didn't really happen in our neighborhood, this discovery may mean that black hole binaries like this one may be much more common than we previously thought. And if pairs of black holes are so common, it can make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide there are in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in about 4.5 billion years. Oh, I can't wait. Now, have you heard that we might be living in a black hole? I'm not kidding. Such a scary theory does exist. See for yourself, black holes pull inside everything they see. But what if one black hole has already engulfed us long ago? Surprisingly, some physicists deem this theory somewhat plausible. For example, Dr. Nikodem Poplovsky, a theoretical physicist from Indiana University, states that everything that a black hole swallows may turn into a new universe inside the hole or on the other side of it. Who knows? Maybe our universe used to be a quite different place until it got pulled into a black hole. The theory of white holes is closely connected with the previous idea. While black holes swallow all the matter so that not even light can escape, white holes are something quite the opposite. These formations are believed to spit out everything that black holes have pulled in. In other words, a white hole is the hypothetical area of space-time that nothing can enter from the outside, but light and matter can escape from it. As for a black hole, on the contrary, you can only enter it from the outside, but can't get free afterward.
How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later thanks to a follow-up investigation conducted by the European Space Agency Exoplanet Hunting Spacecraft, CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo. And in the case of our shiny world, its albedo mystifies scientists. All because most planets that are not ice worlds, or planets with thick layers of reflective clouds like Venus, normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT 9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are two ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT 9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, and ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP 121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP 121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP 121b is also pretty bizarre, to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But if these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP 121b is so close to the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP 76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, But that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun. But its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star, if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size.
Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered Peg 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes, there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside. And almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's grand tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. And it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed, out of all the material flying away after the big crash. There might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler 107b and Kepler 107c are a pair of planets that orbit a star similar to our Sun in the Kepler 107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler 107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler 107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago, but since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helps scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts. Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the Sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the Sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the north pole is pointed at the sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light-years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the 3-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how three stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X-solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. they won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between two stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns. There's only one star in our solar system, the Sun. And all the planets orbit this star. But there are also systems where a planet orbits 2 suns. For example, Kepler 16b. It's an inhospitable and cold place, made of half rock, half gas. But the coolest thing there is that if you visited this planet, you'd see 2 sunsets and have 2 shadows. But astronomers seem to have found something rarer and more bizarre. There might be a planet that orbits 3 stars at once. The GW Orionis star system is around 1,300 light-years away from our planet. It's composed of 3 orange rings. They're made of dust and nested inside one another. In the center of this system, you can see 3 stars. 2 of these stars are binary. It means they orbit each other. The 3rd star revolves around them. Scientists have found out that the 3 rings are misaligned. The innermost ring swings widely in its orbit, and the outermost ring has a tilt of 38 degrees. So, astronomers came up with 2 theories. The first theory says the break in these rings occurred because 3 suns created torque at the center of the entire system. Torque is a gravitational force that always acts toward the center. But sometime later, this theory was written off. There wasn't enough turbulence in these rings for this theory to work. The second theory claimed that this phenomenon could be happening because a planet formed inside one of these rings. A young planet could affect the gravitational balance of the 3-ring system and be the reason they were spread so far apart. There's a specific gap in the dust cloud. Based on its size, the planet we're talking about must be a large gas giant the size of our Jupiter. All space objects have been formed thanks to gravity pulling matter together. If there's even the slightest rotation at the beginning, the spin rate increases with time, especially when an object starts collapsing. That's why all space objects rotate, including dust particles and even black holes. Black holes lose their mass because of a thing called Hawking radiation. Their event horizons are becoming smaller, but this process is very, very slow. A black hole's event horizon is a point of no return. It's like a boundary that surrounds a black hole, and nothing, including light and radiation, can escape once it crosses this boundary. The average black hole would need billions of times the age of our universe to disappear completely. Our home Milky Way galaxy might also contain a supermassive black hole, but we're in no danger. One of the closest large black holes, V4647 Sagittarii, is most likely 20,000 light-years away. It's safe to observe the effects black holes create from a distance. Problems start when you get too close because of their mind-boggling gravitational force. Galaxies can consume one another, which is one of the ways how they evolve over time. Our closest neighbor is called Andromeda, and it's currently munching on one of its satellite galaxies. In the past, Andromeda ate at least 2 others. Plenty of star clusters are scattered all over this galaxy, Andromeda must have stolen these stars from other galaxies. Scientists have finally managed to identify those stars. They have tracked them back to galaxy mergers that happened billions of years ago. 10 billion years ago, our home galaxy also went through a collision. That's why now its halo isn't like the ones other spiral galaxies have. Scientists first thought it was several small collisions, but then they realized that most of these space objects in the Milky Way came from a single source. It was another galaxy, Enceladus, that the Milky Way collided with. The Milky Way and Andromeda galaxy might collide, but it's unlikely to happen in the next 4.5 billion years. Neutrinos are electrically neutral particles that are so powerful that they can go through miles and miles of lead, and nothing will stop them. Some of them are passing through your body as you're watching this. Neutrinos get formed both in the nuclear reactions inside alive stars and in the supernova explosions when stars go out. These particles are nearly massless. They need less than 3 seconds to get to the surface of the sun, and then they can reach our planet in only 8 minutes. There's a planet, TOI 1231b, around 90 light-years away from Earth. It's similar to our Neptune. It's a gas giant, but the most interesting thing is that this planet is likely to be rich in atmosphere. The planet is over 3.5 times as large as Earth and a bit warmer than we're used to, 134 degrees Fahrenheit. It orbits a red dwarf star, way smaller than our Sun. But this star is also much older. 1 year on the planet is only 24 Earth days long. Even though the planet is close to its parent star, it remains relatively cold. That's because its star is on the cooler side too. Astronomers think they've seen clouds in the atmosphere of this mysterious planet, and maybe they're even made of water. This star and planet system is moving away from Earth pretty fast. That's why scientists easily detected hydrogen atoms that were escaping from the planet's atmosphere. Yep, that means the planet may even have a tail. A hypothetical white hole is a bizarre space object that is the opposite of a black hole. It's intensely bright and was first mentioned by Einstein in his theory of gravity. Most often, scientists talk about white holes in the context of wormholes. There's a theory that a black hole is like some sort of entry point to a tunnel that takes you through space and time. In this case, a white hole might be an exit located somewhere else in the universe. On the other hand, white holes don't necessarily need to be exits from wormholes. They could also be a slow-motion replay of how original black holes were formed. So, the formation of a black hole starts with an old massive star. After it collapses under its own weight, it usually turns into a black hole. But sometimes, quantum processes don't turn a star into a black hole. Instead, they make a white hole that starts spewing out the matter of the original star again. But so far, this is just a theory. Some planets, like Mars and Venus, have pretty intense weather with powerful storms. And now, an equally strong space hurricane might have come to Earth. It was a swirling mass of air about 620 miles wide. Satellites spotted the hurricane hundreds of miles above the North Pole, somewhere in the Earth's upper atmosphere. The hurricane was raining not water, but electrons. It lasted almost 8 hours before it finally broke down. It was spinning in a counterclockwise direction. It's possible there are oceans hidden under the surface of the moons surrounding Uranus. Scientists have also been investigating the oceans on Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are hidden below the moon's icy crusts. Uranus has 27 moons. 5 of them are especially big. Those are Umbriel, Titania, Oberon, Miranda, and Ariel. Back in the 1980s, when people sent Voyager 2 to get us some images of these 5 moons, scientists found out that they had lots of craters and were made up of ice and rock. Pictures astronomers got then also showed signs of liquid water. It was erupting from the moon's depths and freezing on the surface. One of the most plausible explanations was the oceans under the surface. As a moon moves around a planet, the magnetic field of that planet tugs at it. That is how the moon stays in its orbit. This tug generates an electrical current that transforms into a magnetic field. Such a magnetic field is called induced, and subsurface oceans might be the reason why this induced field can be produced. Saturn is well known for its famous rings, but Neptune, Uranus, and Jupiter also have rings. At the same time, Saturn has something really special we've never seen on any other planet. It's this huge hexagon storm moving around the planet's north pole. Each of its sides is almost 7,500 miles long. That's an area so great, we could place almost 4 Earths inside. According to thermal images, this hexagonal cloud pattern goes down into Saturn's atmosphere for around 60 miles. The planet is hiding behind thick clouds, and sunlight can't get through them. That's why astronomers can't see what exactly is going on there. But there are theories. Saturn is a gas giant. When gas deep inside the planet gets heated, it strays further out. Huge amounts of energy are released along with that gas, which makes it rise, expand, and lose density. The same processes cause hurricanes and tornadoes on our planet. On Saturn, whirling gases come out of a high-pressure zone located within Saturn's outer layers, and these gases trigger a powerful storm of such an unusual shape.
You hear some noise in the street and rush up to the window to check what caused it. You look up at the sky and just stand there, speechless. The moon is giant. It looks much larger than usual, and it's both beautiful and scary. So what would your life be like if the moon moved twice as close to Earth as it is now? Unfortunately, it would be quite a catastrophic scenario. You see, the moon has a pretty strong gravitational pull on Earth's oceans. It produces 2 high tides and 2 low tides per day. But with the moon so close to us, the tides would get 8 times higher. Some regions would be completely covered with water during the day. The water would only retreat at night. Many islands and highly populated coastline territories would become uninhabited because of this. Many other regions would experience frequent devastating floods. But if you think it would be the only consequence, let me tell you this. The moon also has a tidal effect on dry land. That's why if our planet's natural satellite was to suddenly relocate, its gravitational pull would increase, making waves of energy reverberate throughout the planet. This would affect Earth's crust, triggering earthquakes and starting volcanic eruptions. Now let's leave Earth and the giant moon for a while and have a look at Jupiter's moon, Io, which is the most volcanically active world in our solar system. This volcanism comes from the push and pull from Jupiter's gravity. 2 other moons of the gas giant also have an effect on poor Io. That's why Io's surface is littered with hundreds of volcanoes. Most of them are spewing sulfurous plumes high above the surface of the moon. Our planet might face the same fate should the moon move so close to it. And that's not all. Earth's spin would start to slow down over time. Look, the moon's gravity pulls the oceans, and the resulting friction between the water and the ocean floor slows Earth's spin. Yes, Earth is slowing down even now as you're watching this video, but this process is almost imperceptible, around 1,000th of a second per century. If the moon was twice as close to us, the rotation of our planet would slow much more, making days and nights longer. If people managed to survive unexpected earthquakes, high tides, and volcanic eruptions and got used to longer days and nights, they would get an award. Solar eclipses. These spectacular events that occur when the moon passes between the sun and Earth would happen much more frequently. Since the moon would cover a much larger area in the sky, it would pass in front of the sun more often. People on Earth would be able to see the sun's outer atmosphere, called the corona. It would shine beautifully around the silhouette of the moon. Such solar eclipses would also last much longer. But what if the moon didn't shorten the distance overnight? What if it was a much slower and much more gradual process? Then our planet's crust would shift more slowly. Tides wouldn't change so dramatically either. This would let living creatures on the planet get used to the new conditions and adjust in time. Longer days and nights would likely change the climate, and animals would have to evolve to adapt to it. their eyes would have to change to be able to deal with brighter moonlight at night. Prey would have to learn to hide better, but predators, on the other hand, would have more advantages when hunting. But what catastrophe would have to happen to make the moon move so close to Earth? Well, it could be some massive object, like a giant asteroid passing very close to the Earth-Moon system. If the moon was in the way of this space traveler, it could take energy from Earth's satellite, which would cause the moon to spiral towards our planet.
Imagine stepping out of your spacecraft and setting foot on the surface of the moon. Under your feet, the ground is covered with a fine material that looks like powder. That's lunar dust. You look around and take a lungful of fresh air. It smells very different from the air on Earth, but still nice. Now, unfortunately, this is a highly unlikely scenario, and one of the reasons is that the moon has almost no atmosphere. Earth's natural satellite is too small, less than 2% of our planet's mass. That's why it doesn't have a magnetic field strong enough to keep an atmosphere. But even if the moon had it, solar winds would immediately pull it away. But if you could visit the moon 3 or 4 billion years ago, oh, you'd see a very different picture. At that time, the moon most likely had an atmosphere. It formed at the times when powerful volcanic eruptions were rocking the satellite. Gases spread all over the moon's surface. It happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurling high into the air, falling to the ground, forming lava flows. That's how the basalt basins appeared on the surface of the moon. At one point, scientists on Earth got their hands on samples brought from the moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggested the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days it's around 240,000 miles. That's why the moon looked much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. Neither was I. At the same time, the most recent studies have confirmed that our moon actually does have an atmosphere. It's composed mostly of hydrogen, neon, and argon, and contains some very unusual gases, like potassium and sodium. You can't find them in, let's say, the atmospheres of Mars, Venus, or Earth. Sadly, such an atmosphere isn't suitable for us oxygen-dependent creatures. But guess what? There's loads of oxygen on the moon. I know, it must sound confusing, but the thing is, this oxygen isn't in its most common gaseous form. It's trapped in a layer of rock and dust covering the surface of the moon. This layer is called the regolith, and it contains up to 45% oxygen. So, does it mean that if people learned how to extract this oxygen, we would be able to live on the moon? Not so fast. The oxygen in those rocks is very tightly bound into the minerals, and to break these components apart, we'd need tons of energy and special equipment. But if people managed to start this process, the moon would deliver quite a lot of oxygen. Now, there's a theory that the moon might have been formed during a collision between Earth and another planet. This planet must have been smaller, the size of Mars. It probably happened around 4.5 billion years ago. Another theory claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet, and that's how the moon appeared in the sky. And the least exciting theory claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. These days, the Moon is the fifth largest natural satellite in our solar system. It's also one of the densest, second only to Jupiter's satellite Io. Most likely, the Moon has a tiny core, no bigger than 2% of the satellite's mass. About 420 miles wide, it consists mostly of iron and sulfur. The Moon's surface is dark, even though Earth's natural satellite is the brightest object in the night sky. But in reality, its reflectance is just a bit higher than that of asphalt. You might have heard that the Moon, along with the Sun, causes tides in the oceans and seas on Earth. The satellite's gravitational pull creates something called the tidal force. It makes the water bulge out on the sides that are the closest to the Moon and farthest from the satellite. These bulges are what we know as high tides. But what not so many people know is that the Moon also causes rocks to rise and fall, just like it does with water. Of course, this effect doesn't look as dramatic as ocean tides, but it's still noticeable. Earth's solid surface moves by an inch or so with each tide. Now, not only does the Moon cause tides on our planet, but it also slows down its rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. You should really cut those. If one day it floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the Moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Since the Moon doesn't have an atmosphere, nothing protects it from extreme temperatures. It gets incredibly cold on the night side, minus 390 degrees Fahrenheit. Meanwhile, the sunny side is literally boiling, with a temperature of 250 degrees Fahrenheit. Another thing the Moon can't protect itself from without an atmosphere is meteorites. That's why the surface of the satellite is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. The Moon is less seismically active than Earth. That's why these craters and other ancient formations stay in perfect condition for centuries. But even though the Moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. They start several miles beneath the surface. One theory suggests that they may be happening because the Moon is shrinking as its insides are cooling. Scientists say the Moon has become around 150 feet skinnier than it used to be several 100 million years ago. So, how does it work? Well, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the Moon. It's shrinking and it's wrinkling. But unlike a grape, the Moon doesn't have any flexible skin. Its surface is hard and brittle. So as the Moon gets smaller, the crust cracks and breaks. Its sections get pushed over neighboring parts. Researchers are sure that such faults are still active and likely responsible for the quakes shaking the Moon. Some of these quakes are pretty strong, up to 5 on the Richter scale. When you look up at the Moon, you always see the same side of Earth's natural satellite. Like our planet, the Moon rotates around its axis, but this rotation lasts around 27 days. This is the same time the Moon needs to orbit Earth. Such a phenomenon is called tidal locking. Before space exploration started, people had never seen the other face of the Moon. They didn't know what the far side looked like. While the near side of the Moon is mostly large plains covering impact basins, the far side is rugged and cratered. The crust is thicker there, with less evidence of volcanic activity. Oh, by the way, the Moon isn't perfectly round or spherical. It's shaped like an egg. When you're looking at it, one of its small ends is always pointing at you. Yep, right at you. This is the reason why the Moon's center of mass isn't its geometrical center. In reality, it's a bit more than 1 mile off-center, like a poorly made golf ball.
A recent study claims that the Moon has a tail. and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. Mathematicians claim white holes might exist. Unfortunately, scientists haven't found one yet. Even if you saw a white hole, you wouldn't be able to enter it from the outside, but you'd notice light and matter leaving it. Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could already be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness in April. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. Our Milky Way galaxy and the Andromeda galaxy, our closest neighbor, are going to meet. But it'll happen in about 4 billion years. When they collide, an enormous elliptical galaxy will be formed. There might be more water on the moon than scientists thought before, and not only on its dark side, but also its sunlit side. This water is likely to come in handy during the already planned missions in the future. Cotton candy exoplanets are particular planets outside of our solar system, also called superpuffs. They have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, these planets are enormous. The Juno mission has noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet. These are 2 kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at a height of 60 miles above massive thunderstorms. In the universe, there are not only dwarf planets, but also dwarf galaxies. They have from 1,000 to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. A storm the size of our planet keeps raging on Saturn. It's called the Great White Spot. The storm has a tail of white clouds, and it encircles the entire planet. The storm occurs every 30 years or so, when Saturn's northern hemisphere tilts toward the sun. At first, the storm is indeed just a spot, and then it starts stretching in length. That's because the Great White Spot is a huge system of thunderstorms. But the main mystery puzzling astronomers is where the storm gets its energy from. Some scientists think it might be powered by the sun. Others disagree. They say the storm's cloud pattern only makes sense if there's an internal heat source that can power the winds. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also very hard to find. Rogue planets don't produce light. Neither do they emit heat, which means they can't be seen in infrared light. But not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. The moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. Scientists often discover strange things in space. Many of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They aren't the remains of supernovae or a bizarre optical effect. Some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between black holes. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last for mere milliseconds. Most of these fast radio bursts came from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source was a magnetar, just 30,000 light-years away from our planet. Any liquid floating in outer space forms itself into a sphere. This phenomenon also occurs in low Earth orbit. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. Astronomers saw the star for the last time in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in an extremely bright supernova, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. In billions of years, the universe is likely to expand so much that we won't be able to see any stars in the sky. All planets in the solar system emit radio waves. They're especially strong if we talk about Jupiter. This planet has the biggest and most powerful magnetic field. But astronomers couldn't detect any radio waves coming from a planet outside the solar system. That is, until 2020. The signal scientists recorded came from a gas giant, Tau Bootes. It's 51 light-years away from our planet. Thanks to this signal, astronomers managed to find out a bit about the planet's magnetic field. And in the future, this will help to learn more about what's happening in the planet's atmosphere. Dwarf planet Haumea is further from Earth than Neptune. It's orbiting in the Kuiper Belt. That's a donut-shaped ring of ice objects circling the sun. Elongated Haumea has 2 moons. A day on this dwarf planet lasts 4 Earth hours. All in all, this space body is rather bizarre. It's surrounded by thin rings that likely appeared as the result of an ancient collision. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf. And the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees Fahrenheit. That's hot enough to melt some metals. China's U-22 is a robotic mission to the dark side of the moon, launched on December 7, 2018. On January 3, 2019, it completes the first ever soft landing on the lunar far side. It lands in the Von Karman crater, not far from the moon's south pole. Scientists are interested in this area. Cold, permanently shadowed craters at the poles contain water ice. These ice patches are uneven and are likely to be ancient. In the south, most of the water ice is concentrated in craters, and at the North Pole, it's spread more sparsely. In any case, this ice can be used once a long-term manned mission lands on the moon. Anyway, Several days after U-22 lands, it closes down its operating systems and hibernates through its first lunar night. It wakes up on January 29, 2019. All its tools operate normally. The rover travels 390 feet during its first full lunar day. One lunar day lasts for about 14 days, and a lunar night has the same duration. Moving and exploring during the day and switching off during the night becomes the rover's routine. It's the 8th lunar day when U-22 stumbles across something incredible. This discovery makes the scientists put off all other plans for the mission. They focus on figuring out what the strange material found by the rover is. In the beginning, this lunar day is no different from any other. It begins on July 25th, when the rover starts making its way through an area pockmarked with tiny impact craters. U-22 is helped and monitored by the driver team from the Beijing Aerospace Control Center. On July 28th, the team is preparing to shut the rover down for a midday nap. The sun is high in the sky. It means there are high levels of radiation and scorching temperatures that can damage the machine. Before powering U-22 down, the scientists are looking through the pictures taken by the rover's main camera. That's when they spot it, a small crater filled with something that looks shockingly different from the surrounding landscape. Unable to identify the gel-like substance, the team orders the rover to check this bizarre finding. U-22 cautiously nears the crater to examine the weirdly colored stuff. The machine uses special equipment that detects the light reflected off the substance. It's supposed to help the researchers to understand the structure of the material. Unfortunately, the nature of the unusually colored finding has remained a mystery for over a year. No wonder that both the finding and the fact that initially there were no images of the enigmatic stuff sparked curiosity all over the world. The only available description of the substance was that it looked like a randomly colored, shiny gel, something that's rather odd for the dusty, arid surface of the moon. But finally, the mystery seems to have been solved. The researchers have analyzed the information received from the rover's equipment. As expected, the substance turned out to be made up of rock, greenish and glistening breccia, in a sample no larger than 20 by 6 inches. It's kinda like a geologic version of Jell-O salad with fruit inside. If you melt it down, it'll look glassy. Breccia consists of sharp stones joined together by a chalky substance. The sample found on the far side of the moon is made up of a mix of different minerals. The main is a type of silicate that's one of the most common components in both the moon and Earth's crust. The piece also contains some glass, which means it could have formed during a volcanic eruption. But volcanic activity on the moon stopped more than 3 billion years ago. That's why the researchers are almost sure it's unlikely to be the source of the unusual finding. The material could have been created by a massive asteroid, comet, or meteorite that once hit the moon. During the collision, the pressure and temperature were so high that huge amounts of rock instantly melted. Some pieces cooled down rapidly enough to form glass. The rest gathered at the center of the impact crater and grew colder more slowly, forming a new rock. The substance was likely not formed in the Von Karman crater, but in the nearby Finsen and Alder craters. The hollow where the rover made its finding was just 7 feet across. Whatever left it had to be no wider than an inch. But then, it would be too small to create such a large piece of breccia. It's interesting that the material is similar to the samples collected by the astronauts from NASA's Apollo missions. One of those samples was made of dark, broken shards of minerals glued together. It also contained some black, shiny glass. It's not clear, though, whether it's the same as the stuff discovered by U-22. When the rover took photos and made its measurements, it was rather dark in the area. The quality of the images isn't that great. The experts also explain that the mission is examining a previously unexplored area of the moon. That's why they don't have any samples from that region to compare them with the greenish, shiny substance U-22 found. But if their guesses turn out to be true, then the far side of the moon might have more in common with the Earth-facing one than we used to think. But What's so special about this dark side of Earth's natural satellite, and why can't we see it? It's all because of the phenomenon known as tidal locking. Earth's only natural satellite rotates around its axis once in 27 days. It's the same amount of time it needs to go round our planet. That's why you always see the same face. To be precise, 59% of the moon's surface is visible to people. It means that you can catch glimpses of the satellite's far side at some times of the year. The moon's side we can't see is quite different from the one facing Earth. It doesn't have dark spots that are visible at night. Those are lunar basaltic plains called lunar maria. They were created by ancient volcanic eruptions. Those happened about 3 to 4 billion years ago. Instead of plains, the far surface of the moon has countless craters and tall mountains. One of the ideas about such a striking difference between the two sides is based on the collision theory. It claims that billions of years ago, Earth collided with another planet or some other massive space body. After that, the debris from this collision crashed with something that would later form our moon. That's why the satellite's landscapes differ so greatly. A more recent theory suggests that the Earth-facing part of the moon is warmer because of the heat radiated by our planet. During the period of volcanic eruptions, it was cooler on the farther side. That's why the minerals there became solid faster. They formed a protective layer shielding the moon's insides against the meteorites. But each impact left an impressive crater. At the same time, a much softer crust on the front-facing side of the moon spewed lava every time a meteorite hit it. After this lava cooled down, it covered the impact craters. Even though the far side is often called dark, both sides get almost the same amount of sunlight. The side we see looks a bit brighter because of the glow coming from Earth. There are two reasons why people are interested in exploring the far side of the moon. After leaving our planet, many radio waves get blocked by Earth's natural satellite. If astronomers could build their radio and optical telescopes on the dark side, they would get much more data. There would be no problems with any kind of interference. The telescopes would also be shielded from the glare of daylight coming from our planet. If telescopes were set up inside craters, they would also be protected from solar radiation. Astronomers would be able to get an incredibly clear view of the far regions of the universe. Plus, scientists believe there are great amounts of helium-3 on the opposite side of the moon. Earth is protected from solar winds that carry this gas by its magnetic field. But our natural satellite doesn't have such a shield. That's why experts believe the moon can be a perfect place for helium-3 mining. This rare element can be later used as the fuel for fusion reactors. Look up. Find that little yellow dot. That's Titan. It's Saturn's largest moon and the second largest moon in our whole solar system. And it might be the only place in our solar system where there's liquid water, besides Earth. Plus, it has an atmosphere that serves as a shield against solar radiation and cosmic rays, just like Earth. If life was a house, Titan would have a lot of the bricks you'd need to build it. Strap in, you're heading over there. It takes a long time to get to Titan, but you know, the magic of YouTube. Here it is, a bit bigger than our moon and a whole lot heavier. It's even bigger than Mercury. That means its gravity is still pretty weak. You'll feel 7 times lighter here than on Earth. At the local gym back home, you can lift 150 pounds. On Titan, you can lift more than 1,000. Ha! Looking good. The surface is mostly made up of ice. It has small mountains, craters, and a few cryovolcanoes. Basically, the same as a regular volcano, but instead of lava, this beast spits out water, ice, ammonia, and methane. There are lakes and clouds, kind of like a canyon would look like on Earth. But here, there's only a tiny difference. Everything is covered in thick fog, and sometimes it hails frozen methane. On Earth, we use methane as fuel because it burns. But on Titan, there's no oxygen. Can't get a fire going on this hunk of rock. No oxygen means you need to put on an oxygen mask, but you don't have to wear a whole spacesuit like on our moon. Titan has a stronger atmosphere. But you packed a sweatshirt, right? It's gonna get pretty cold soon, like negative 300 degrees cold. The coldest it ever got on Earth was negative 128, and that was right at the South Pole. It's so cold because it's so far from the sun, almost 900 million miles. Anyway, that dense fog and atmosphere stop the sun's rays from warming the surface. Sounds kind of extreme, but so is life. It can survive almost anywhere. Take the bacteria Dano, some long Latin word. It can survive radiation and extremely low temperatures. It even survived a whole year in outer space, on the outside of the International Space Station. Titan would be a piece of cake compared to that, especially if we drilled down a bit. Many scientists believe there's a whole ocean under the surface of Titan. Saturn's gravity gives Titan's core a little heat boost. Plus, there's ammonia in that ocean. It's like Titan's version of antifreeze. As long as the water stays liquid, life's got a pretty strong chance of success. So what's down there? Scientists have actually found real evidence that Titan might already have life on it. Here, check out this microscope. This is C3H2. It was discovered by this weird group of antenna things living in the desert in Chile. It used 66 antennas, all pointed at the same place in the sky. This C3H2 molecule can act as a building block for DNA, the code of life. Some people think that these molecules were around on our planet billions of years ago, just when life began. Scientists also checked it out firsthand with a probe that actually landed on Titan. Turns out those desert antenna things were right. Titan shot to the top of the list of places we could one day live on. Sorry, Mars. NASA has a new project, the Dragonfly mission. They're going to send a drone out there and explore Titan even more. The mission's still about 6 years away, and the rocket will reach Saturn's moon 9 years after that. So we're going to have to wait a while before we pack up and move to Titan. After the Dragonfly drone lands on Titan's surface, it's going to whiz around like a sort of double helicopter. It's going to have 8 propellers, 3 feet wide. Since there's weak gravity, that's more than enough to give the drone good cruising speed. It'll be able to fly about 2 miles straight up and take off and land vertically, like a regular helicopter. The main problem with the whole thing is the drone's batteries. Scientists invented a generator that converts thermal radiation energy into electrical energy, whatever that means. One battery charge should be enough for several hours of continuous flight. The Dragonfly is going to be carrying a lot of research equipment, so it's not like those drones people fly in the park on a Sunday. It's going to weigh about as much as 3 ostriches. It's going to have 2 drills, a bunch of sensors, a spectro thing to find out what chemicals are lying around, and it's also going to have its own weather channel with a ton of instruments to measure temperature and clouds and stuff. And like any gadget nowadays, it has a camera on it. Get ready for some beautiful pics of Titan's epic landscape. Nighttime on Titan lasts about 8 Earth days. That's when the drone's going to be relaxing on the surface, recharging and analyzing samples. That's a long time, but it's actually a good thing. Titan's distance from Earth causes a bit of a problem, a delay in communication. When they send the Dragonfly a signal from Mission Control, it has to fly halfway across the solar system. It takes over an hour. In contrast, the signal delay to Mars can be as little as 10 minutes, and the signal delay to the Moon is only about a second. Scientists expect Dragonfly to provide more information about whether we can live on Titan or not. Some experts hope to find a primordial soup there. It's a whole mush of stuff needed to make life. We had that same soup on Earth about 4 billion years ago, and every single living organism that ever existed evolved from this mush of organic elements. If the Dragonfly project's a slam dunk, and Titan does turn out to be habitable, it'll have one more mission, to find a nice place for us to settle down in. But creating a self-sustaining colony on another planet would definitely be the hardest thing humans have ever done. First hurdle, energy production, probably some sort of nuclear power plant. Then comes shelter, for humans and their machines. Those new Titan buildings will have to protect us from the extreme cold and bad weather. Then, drinking water and oxygen. We'd need to invent a way of collecting or engineering both. Then, greenhouses for growing food. We'd also need to mine fuel for transportation. Luckily, Titan's packed full of methane, which is great for fuel. One huge problem: gravity. Because it's so weak on Titan, whoever lives there could lose a lot of muscle mass, making it hard to work and even just live. And there are those pesky cryovolcanoes shooting stuff out at random times. Or maybe we'd need a more drastic, daring idea. How about changing Titan's atmosphere so we can breathe on it and not have to wear about 100 hats and gloves? To do this, we'd need to terraform Titan's surface for a long time. Titan's atmosphere needs to be enriched with oxygen for us to breathe, and it would be great if it was a bit warmer. The next step is to create a biosphere, which means plants. We could turn Titan into a blooming jungle with plants brought over from Earth. But because of pressure and gravity, they'd look completely different from Earth plants. They might all grow super tall, or maybe they'd all shrink down to mini size. We really don't know. First things first, we need to make sure that life is even possible on Titan. Scientists recently thought there might be life on Venus. It's sort of the same size as Earth, and scientists even call it Earth's twin sister. They discovered a gas on Venus, phosphine. Supposedly, it was made by living organisms. Turns out it wasn't true. Well, not really. There is some phosphine floating around, but way less than we first thought. Look, science on other planets is super hard, people. We're always making mistakes like that. The moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020's CD3, are rare. They need to have specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. A transient lunar phenomenon is one of the most enigmatic things happening on the moon. It's a short-lived light, color, or some other change on the satellite's surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes. but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the natural satellite was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. There might be more metals, for example titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would be easier to walk on the moon's surface, but it would be more dangerous too. Your feet inside a heavy spacesuit would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden under the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared in the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. There's no air on Earth's natural satellite, but then how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. But even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. The Earth and the moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The moon creates tides in the Earth's oceans. They pull back at the moon and make it speed up. This, in turn, moves the satellite to a higher orbit. In prehistoric times, the moon was way closer to our planet than it is now. Luckily, we aren't going to lose the moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the moon away with such a force. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the Moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the Lunar Cataclysm. This interval lasted several hundred millions of years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. There might be a labyrinth of lava tubes on the Moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface, about 30 miles long and 60 miles wide. The cave's likely to be the result of 3 billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the Moon's surface, discovered by NASA, might be the openings to lava tubes. The Moon's orbit around the Earth isn't a circle, it's an oval. That's why the distance between our planet and the satellite varies from over 225,000 miles to more than 250,000 miles. There's very little seismic activity going on inside the Moon. Yet, many moonquakes caused by our planet's gravitational pull sometimes happen several miles below the surface. After that, tiny cracks and fractures appear in the satellite's surface, and gases escape through them.
Since 2007, astronomers have been receiving super-strong and ultra-bright radio signals that last just a few milliseconds. Such mysterious flashes are called fast radio bursts. They seem to be coming from billions of light-years away. Not so long ago, researchers were lucky enough to capture a repeating radio burst that flashed 6 times in a row. Who knows? It might help us crack the puzzle of these signals. But hold on, it's just the first mystery on our list. If nuclear pasta does exist, it's the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance is squeezed into spaghetti-like tangles of material. It can break, but only after you apply 10 billion times the pressure needed to shatter steel. That single, high-energy neutrino that hit Earth in 2017 wasn't extraordinary on its own. Scientists observe such neutrinos at least once a month. But it was the first one to arrive, carrying so much information about its origin that astronomers could actually point their telescopes in the direction it had come from. They found out that the neutrino had been flung at our planet around 4 billion years ago by a flaring blazar, a supermassive black hole at the center of a galaxy. Saturn's moon Hyperion is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity which is flowing out into space. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras illuminating the planet's atmosphere. When a team of astronomers at Louisiana State University first spotted this star, they were totally baffled. The object, nicknamed Tabby's star, dipped in brightness at irregular intervals and for odd periods of time. Sometimes the difference in brightness reached 22%. Could it be due to the activity of some alien megastructure? Unlikely. The main theory claims that the star is surrounded by an abnormal ring of dust, which causes the darkening. DJI-SAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone. Unlike other galaxies of this kind, which are usually found in clusters, it can mean that DJI-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Massive objects curve light so much that it can distort the images of objects behind them. When astronomers used the Hubble Space Telescope to detect a quasar from the early universe, they used their discovery to calculate the expansion rate of the universe. Strangely, they discovered that, currently, it was much faster than it used to be. That finding contradicted other measurements. We still don't know if our theories are wrong or if something bizarre is going on in our universe. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star. But this theory hasn't been proven yet. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre, elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most enigmatic thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Dark matter is believed to make up 85% of the universe, and researchers used to be sure it was everywhere. But in March 2018, a team of scientists discovered a peculiar galaxy that seemed to contain little to no dark matter. Later, though, it was proven that this space oddity did, in fact, contain dark matter. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this yet. Planets orbit stars, moons orbit planets, then why can't there be moons, also known as submoons, moonets, and muons? Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet.
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation, or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the Sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the Sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the Sun and from space. But even though Saturn is protected by its magnetosphere, the Sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled. Sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the Aurora Borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus the strongest ones, X-class flares, have been getting stronger and more common than before too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it.
The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then. From thousands of dollars worth of treasure to brand new phones and ancient cities, let's dive into the water and see what we can find. Imagine going to the river to enjoy a boat ride. Who wouldn't want to take a couple of pics to make the memories of this trip last forever? Oops, the water splashed. Luckily, you've taken precautions and put your gadget in a waterproof bag. But what if you drop your phone to the bottom of the lake along with this case? This is what happened to some people. A scuba diver and a YouTuber dived into a river popular with tourists and lost some of their gear worth $20,000, including new iPhones and some jewelry. Oops. You might be familiar with the image of a car getting pulled out of the water, either from the movies or TV news. Large cargo vessels sometimes sink, and trucks inside them go along. That's what happened with the Thistlegorm wreck. It sunk in 1941 in the Red Sea, and these Bedford trucks were inside. Want to see something more valuable, like treasure? A British cargo ship was carrying a heavy load of silver ingots, but the vessel sank. Treasure seekers knew there was silver on the ship. Since the 1940s, they've been looking for it. The Odyssey Marine team got lucky. They made the discovery in 2011. The treasure was more than 14,000 feet below the surface. The ship had carried more than 110 tons of silver ingots. Finders keepers! The Odyssey team kept 80% of the treasure and gave 20% to Her Majesty's Treasury. Of course, there were more items on the ship, like letters, teapots, and silk sheets. You can see them in the exhibition called Voices from the Deep at London's Postal Museum. Now how about some underwater art? Sure, here you go, Polynesian moai statues. These statues have been discovered in several areas across the world. For instance, Easter Island is full of different size statues, but many of them can also be found in Cancun, Isla Mujeres, and Punta Nizu, Mexico. Seeing full-body statues from thousands of years ago under the water would probably be a lifetime experience. Gold coins are also popular items found in shipwrecks. Many divers come across coins worth a lot of money. But there's one diver in Florida who truly hit the jackpot. In 2015, they stumbled upon nearly $1 million worth of treasure. The discovery was 51 gold coins, 40 feet of ornate gold chains, and a rare coin that was made for Philip V, the King of Spain. They were once frightening and dangerous, and they still look spooky. Yo-ho! I'm talking about pirate ships. One pirate shipwreck from the 18th century was excavated off the coast of Colombia in 2015. The treasure found there was worth between $4 and $17 billion. It contained precious stones, gold, and many other items. The next one is an underwater city. Neapolis is a city washed away by a tsunami. It was built on the coast of North Africa nearly 1,700 years ago. Divers uncovered the city's remains in 2017. Researchers have also discovered Roman columns, as well as household goods and tools. Now, let's go all the way back to 1503. Portuguese explorer Vasco da Gama was fighting a storm when he lost his ship Esmeralda. The ship was discovered in 1998, but it had to wait for more than a decade to be excavated. Researchers found navigational tools there. They didn't have as much value as Spanish gold, but they were historical treasures. Now, in Amsterdam, they fish for bikes in canals. 1/3 of working Amsterdammers cycle to work. Others use their bikes for different purposes, like exercising, going shopping, and so on. There are more bikes in Amsterdam than permanent residents. Unfortunately, many bicycles and even some cars end up in Amsterdam's canals. The fact that Amsterdam has 165 canals with a combined length of 60 miles doesn't make the authorities' job easier. Obviously, the owners don't throw their bikes into the water. Bikes can end up in the canals because of strong winds, vandalism, theft, or by accident. Every year, authorities fish up between 12,000 and 15,000 bikes. Our next one is a lost city. Heraklion was ancient Egypt's gateway to the Mediterranean. It became submerged and hidden under the sand. This city was famous. Maybe you've even heard about it. It was mentioned in the legend about Helen from Sparta and Paris from Troy. So, how was this ancient city discovered? In the early 2000s, a team of divers found a huge fragment of rock on the seabed and took it up to dry land. It turned out that it was a piece of the statue of Hapi, who was the lord of the river of ancient Egyptians. The team continued searching and found 6 other pieces. Around them, they saw temple ruins, pieces of pottery, jewelry, coins, oil lamps, and so on. Even an old copy of the New York Times. Nah, not really. Granada Underwater Sculpture Park is the world's first, what else, underwater sculpture park. Why is this park so special, besides being located in the beautiful waters of the Caribbean? You can see the park on a snorkeling or scuba diving trip. The sculptures are about 9 to 16 feet underwater. The atmosphere and the experience itself make it special. The sculptures are made from concrete and steel. Some of them weigh as much as 15 tons. They're covered with underwater creatures. The statues were put there to help protect reefs, maintain the health of the ecosystem, and restore underwater life in that area. Now, submarines are designed to go underwater, so maybe you wouldn't expect to see them on this list. But submarines do, in fact, sink. Divers have discovered many submarines. For instance, an Australian submarine was found off the coast of Papua New Guinea more than a century after it had sunk. Now here's another submerged city, but this one was left underwater on purpose. You can see the ancient ruins of Lion City in a lake in China. This lake was created in 1959 when the valley, at the base of Five Lions Mountain, was flooded to create a hydroelectric power station. The 1,400-year-old city, now ruins, got submerged by this flow and stayed this way for over 50 years. It lay untouched at the bottom of the lake until its exploration started in 2001. divers found out that many structures, carvings, guardian lions, and arches were still preserved. Researchers mapped and documented Lion City. They also looked for a way to protect these structures from further damage. In 2011, the city was announced to be an historic relic under protection. When you see the ruins of Lion City for the first time, the view will take your breath away. So don't forget to hold your breath. Imagine swimming in the dark waters. As you're approaching the city, you see its huge walls and extensive carvings. Marvelous, isn't it? The Cancun Underwater Museum is probably the largest museum of its kind in the whole world. It wasn't lost, per se, but now it's home to an aquatic ecosystem. Who wouldn't want to combine scuba diving and snorkeling with a visit to a world-class garden with 500 sculptures? Placed 30 feet under the surface, these sculptures are made from pH-neutral marine concrete so that they can stay on the ocean floor. Plus, here, the sculptures change over time, unlike in a traditional museum. That's because they become part of the underwater environment and a home to various plant and animal species. In one installation, nearly 450 life-size figurines are grouped together to hint at the harmonious coexistence of humanity. There is also the Anthropocene, which is an actual submerged Volkswagen Beetle placed by the Manchonis Reef. Okay, this is not a lost and found item, but this is just, hey, it's a giant jellyfish and I wanted you to see it. This creature is known as the lion's mane jellyfish, and it's the largest known species of jellyfish. So, I'm happy now. And have you ever discovered anything underwater?
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the